let's try another problem for today. Just like the previous problem when we were talking about data types, we are still going to be using data types, functions, and certain commands and whatnot, and strings. So I already just copy and pasted this challenge. It's just going to be the BMI challenge, weight in kilograms, height squared times meters squared, essentially. So I just copy and pasted this whole mess in Replit. So let me try to explain through what's going on here. So we have two established variables, and then we have two functions. We have two input functions, right? Essentially, it's just saying, hey, interact with me. And then how is it, and there's the string inside, which is as evident by the quotes here, which is telling you to, hey, enter your weight in meters, enter your height in meters, and enter your weight in kilograms. So you have these two variables right here, which are essentially both inputs. So once you put an answer for one, it wants an answer for another one. Now let's go to the next part, which is weight as an weight. That's a new variable. We have two variables over here: weight as integer and height as float. So integer integer, which is just another way of saying number, solid number, which is weight. Which is referring to this variable right here, and then float, which is floats are just decimals. Float height, which is height is gonna refer to the original height right here. If you go back here, if you were to click height, it then shows you all the instances of that phrase in general, including the strings. So what next is going to happen is that although that we specifically established two new variables right here, what's happening here, right? So let's just play along for now, just to explain, since just explaining things without really getting anywhere won't make much sense unless you understand it visually. So typically I use freedom units. I don't necessarily pounds, gallons, feet, and whatnot, yards. I don't necessarily use meters and grams and then kilograms and the sorts, but I understand what they are. They're just a form of measurement that the rest of the world uses, which is more comprehensible, but for me, it doesn't make any sense. But I went to a converter and found that, let's just say I'm 6 foot and 200 pounds. So 6 feet would automatically refer to 1.8 meters in height, and 200 pounds is automatically 90.7 kilograms, because you have to understand precise numbers in freedom units do not translate well to precise numbers in the imperial system or empirical system, whatever the hell it's called. So let's just play along. Let's just put our height, which is 1.8 meters, which is 6 feet last time I checked, and enter your weight in kilograms. So let's just say 91 or 90.7, right? And then we'll get an index of 28, right? If that was 90, it would just be 27. So what exactly is happening? How did this become this, right? How did this spit out that? So if we were to go back to the previous, let's go back to the coding rooms right here, and we see what is BMI. This is the equation that we are provided with. So BMI is, we are provided with, okay, BMI 1, and then equals weight, equals this thing right here, which is just where, again, remember the whole idea is that we're just referring to one thing over another. So we're establishing a new variable. Said new variable is referring to previously established variable divided by other previously established variable divided multiplied by two times, as evident by the the brackets over here as power of 2. So you're multiplying two times, not multiplying, but yeah, it's an exponent, right? That's how we recognize it as an exponent to the power of something, right? Rather than just a single 2, because if that were the case, it would just only multiply once rather than 2 times. So okay, this right here is referring to that, and this right here is referring to the previously established variables, and those two previously established variables are referring to these two previously established variables before them. So it's essentially, remember, it's a Russian nesting doll problems. So this thing is referring to that thing, and that thing is referring to this thing, all by name. So in order for the whole thing to function. So essentially, what's happening here is that once let's just say over here, BMI is integer, the new name, equals int, right? That's the int. We need solid number. That just becomes a solid number. Int means solid number, like ones and sixes and 17s and hundreds and triple, quadruple, and so on and so forth. And floats essentially mean decimal points. So we created a new variable once again. Then we asked int, which is a solid. Don't confuse int with input, by the way. I had that for some reason. Had the same issue for some reason. And then you're essentially int, okay, which is bracketed with BMI, and BMI is only referred to one time. So again, it's just a pattern, right? Make a new variable, refer to the previous one, and then just print this variable once again. Okay, this variable right here, just print it once again. It's just essentially, this could really be anything at the end of the day. It doesn't matter what name you put it as long as it has a name, to refer back to it, right? It's the same thing as how weight as integer is referring back to weight, which is up here. It's the same thing as height as float, which is referring back to float. And then, which is also funny, then we created a new variable which refers to both these things right here, which refers both to the previous statements. And then it's equally funny when then we create another variable which with another input, and then we have to summon the previous one before that, and then we print. We just make a new function, the print function, and then we summon the previous one once again. So, okay, cool. What exactly is happening here? Like, still, that doesn't make any sense. How did these two numbers coincide? You see, the equation is right here. BMI equals weight in kilograms and height, height squared, meters squared. Essentially, what is happening here is that we have weight as integer, which is referring to this aspect right here, the previous one, and divided by height as float, which is the previous one. So it's referring, again, remember to what we were talking about, how you're going back to your previous problems, your previous established rules, and then all you're doing is you're just referring back to them. Okay, that's all that's happening. You're referring back to them and saying, hey, okay, what is the rule? What is the parameter for this? Okay, what is the rule for that one? What is the rule before that? Where did you get this? And sometimes where codes usually break is that there's usually a contradiction. It's like, okay, I don't really know what you're talking about because I just, I skipped a flight of stairs, right? It's not cohesive. It's not logical. So why specifically meters and kilograms, right? That's an optional choice. Okay, you could literally write any equation flat out, and it doesn't really matter. This could be in pounds and this could be in feet. It doesn't really matter with any equation you want to do. But specifically, you're doing a BMI thing. You're utilizing a BMI equation. Now, your main question should be or I should say, your main attention should be directed here. We established two previously mentioned variables. Okay, why is weight considered a solid number, but height is not, like float? Why is it not the case? From what I understand, when you're converting certain things, when you say, oh, I'm 6 feet, right, for example, it automatically translates to 1.8 meters. And we already established that decimal points, anything that is other number, is automatically a float, because decimals are floats. And that's how it essentially constitutes. And then let's just say we have an int. What is int? Int is a solid number. It's that doesn't include any decimals behind or forward or within the middle of it. 50, 27, 30, 60, 89, 100, so on and so forth. And when you place your when you place 1.8 meters, you're placing a decimal function. You're placing a decimal function, and said height is usually in decimals. So it makes sense when you put, okay, hey, 1.8 is a decimal and it's a float, but it's not a solid number. So I can't put integer. I have to put float. Therefore, it works just as intended. But wait a minute, 200 pounds is actually 90.7 kilograms. You'd be correct. Okay, so you just have to literally change these two. Change this to be float and this to be float, and then all you have to do really is just change the variables, not to confuse yourself, because these variables really are there for you. So all you're doing here is that you're just creating a variable, creating a function, creating referring to the previous thing, creating a new variable, referring to the previous thing, and then doing a little bit of extra things here. That's the BMI. That's the equation. And then let's just say, I'm pretty sure you can do this with all kinds of equations if you want. Let's just say you have BMI as integer. Okay, BMI as integer, which is creating a new variable. Solid number, refer to the previous thing, which is right here. Instead of refer to the previous thing, print it out, because if you just don't have any printing out, it's gonna be stuck. So you have to print it out, then it refers to the previous thing, and then it spits out the number. Okay, so just to give you, just to show you, because I feel like I'm losing you here. So allow me to just so take a look at this, right? Take a look at this, right? I changed these two things as floats right here, right? So as usual, these two are decimals. So in order for you to play technically with me, really, so as usual, 200 pounds is 90.7 kilograms, which is a float, which is a decimal. Okay, 6 feet is 1.8 meters, which is a float, which is a decimal. Point anything is automatically a float or a decimal. Interchangeable. It's just a mentality of thing. It's just pattern recognition. So once you have that down, let's just put in, enter your height in meters. Okay, don't mind if I do. So that would be 1.8. Okay, enter your weight in kilograms. Okay, cool. 90.7. And then it would just give it would spit out 27. So essentially what's happening here is that all you're doing really is just referring to these two variables, okay? Because I have to change their names to make much more, to help me out here and help to make things more cohesive. You're just changing the name, and then you're changing the function, and then you're referring to the previous thing. So really, this just could be a whole mess of things, I presume, okay? And even if I, mess anything up here, that could just be an opportunity to learn. So 1.89, 2.768 doesn't really make any sense. And then it would still, regurgitate something, because all it's doing is that it's just point this thing right. Oh, hold on, wait. This thing right here is dividing this other thing, which is multiplying 2 on both sides, right? And then it just make a new variable, solid number, summon the solid number input thingy function, refer to the other thingy right here, which is the previous established thingy, and then print, and then refer to the previous thingy before that. And then, that's about it. And that's how it really functions at the end of the day. Nothing really to it. Okay, just to prove to you this mess, let's just make everything an integer. Let's just make all the commands an integer, right? These two, both of these, for example, right? Don't worry about these, because these should be doing as intended. But it's no longer a BMI calculator anymore, because we're just messing with it just to demonstrate to you the difference between integers and floats on how you can make certain equations with them. So I don't know, 6, cool. 200 pound and 5, right? The equation still occurs, right? It's not, and the computer doesn't recognize it as an actual BMI. You have variables so you could distinguish what's going on here. Oops, not this, just this mess right here, so you can refer to it constantly. You establish a set of rules, you create foundation, you build on that foundation. Just think of it as if you're building a building upside down. So, that's about it, and I hope I've been clear.